welcome to our first class for object-oriented programming. We're going to go over the general class structure, what I'm planning on doing. And the idea is we'll have a series of videos covering a bunch of topics that we have in the schedule. First, a review of our initial object-oriented programming stuff. Some more of that and some case studies, like what you'd actually do with object-oriented programming in the real world. Review of data structures, most of what we did there. Doing a quick review of that, things like stacks and queues and that kind of stuff. And some more on the everyday use of object-oriented programming and data structures. So I know a lot of this is theory, and that can be boring. But the general idea here is that object-oriented programming is used in everything. So we're going to look at some examples using GitHub Desktop and opening that up and checking out objects that we did in class, making some modifications to those, that kind of thing. But first we want to go over the basics. So we're going to have videos like this once a week, and they'll probably be at the beginning of the week, like this one. And they'll be informative videos that'll have reviews of what we've done in class, some new material, some things for you to check out, and some optional activities like posting in the discussion boards, part of checking out some of the stuff. So kind of the idea there is that you can watch the videos, review what we learned previously in class, get that structure of how objects work, attributes, methods, events, inheritance, polymorphism, constructors for objects, those kind of things. And see some of those in the real world. Play with some examples using GitHub Desktop, Visual Studio Code, some different IDEs, and having a good time doing it, and making sure that we understand the basics of that. A lot of programming you're going to use is going to do that, and things like PowerShell scripts. Those are going to have the same kind of thing. So if we look at, let's say, a PowerShell script for deleting old files. And this is an example of something you do on the IT support side. Alright. So let's say you're not interested in being a programmer in the long run, but you do want to do support. Whenever you look at any kind of scripting done in PowerShell, like this example here, we see looking at files is really just looking at a series of objects, right? So understanding how an object is defined, a group of attributes, methods, which are the functions, right, to work on those attributes, and different events, and responding to events is really important. So going over those kind of things in detail, at least for a few minutes, to give you some time to review them and prepare for some tests. So the general grading structure is like this. So everything that was previous work, we don't know for sure if you can get to all that. Maybe you had some of that stuff on campus that you were working on, right? That kind of thing. So everybody gets an A for that, all right? And then we have an exam and a final exam that we'll take that will go over object-oriented programming, data structures in general, those kind of things. But if you get into a scenario where you're sick, you have a family member that's sick, something like that, there's a special grade exemption homework assignment. So the idea is, if you can't get the test done for whatever reason, you just fill this out and say, I can't, I'd like to be exempt from grade. So then I'll just give you an A, and we're good for the course. I'd like you to participate as much as you can, but in these circumstances, we're not sure, right, if everybody's going to have consistent internet access, if you or a family member gets sick, those kind of things. So I want to have an option here. So that's what this grade exemption is about. So there'll be other tests that'll show up here. One test and the final exam. I'm going to leave all the other homeworks and stuff there. So if you want to work on your project and do it, right, you can do it. You might have some free time. So they're all there, but everything really is optional, right? So, um, as a matter of fact, if you can't get in to do this great exemption, I'll also flash and put up in the notes for the video my address. You can send me a letter, snail mail. I'll put my phone number in the notes, email. If you for any reason can't complete the course, you try and something happens, you just let me know and we'll take care of it. Okay? So that's the general idea. We're gonna have a good time checking stuff out, but if you have issues getting work done, don't worry about it. All right? So um, if you have any questions about that stuff, you can contact me certainly any way possible. So the general idea of what I want to cover for this week really encompasses what we did with this presentation. We looked at the three major pillars of object-oriented programming. So inheritance, meaning I can create something like in our example, a base wrapper and then a Griselda wrapper, or you could have a mammal, right? And from that mammal you have a canine, and then that canine is subclassed to a terrier or something like that, right? The idea here is this constant flow of a hierarchy exhibit itself in any kind of project that you could work on. Most object-oriented development is done because most projects are a series of objects, right? We look at modeling uh, things using something like MVC from Model View Controller. We talked about this in class previously, right? So, Model View Controller is a popular way to do this. There's other ways that you can do it, but the idea of having a model for whatever your data is. So let's say you're trying to map coronavirus data. Okay, so there's lots of dashboards, different things you can look at online. ESRI has a coronavirus map. That's one of their online applications. This has a series of data objects, right? So there's a model for a country, um, a model for the entire globe, all countries together. And inside a country, there's models for states, provinces, that kind of thing. So you've got United States, right? I can select the United States. That's a country model, and inside there is state models themselves, right? So pretty much everything is going to deal with some kind of objects. In working with those objects, excuse me, the model view controller, in this case, statistics about coronavirus would be in our model. Um, we'd have series of views like a map view, table view, right? Other details available in different views. So picture each one of these different dashlets that I can minimize and maximize. Each one of those dashlets are part of some JavaScript web framework that's putting this together, right? So we've got a dashlet here for confirmed cases by country, region, etc. See this widget header, this widget itself. This is the view part of MVC. So the model is the actual data, and then the view is each dashlet, and there's some kind of controller, some part of the JavaScript source code, something here in sources, I'm not sure, where in assets there's probably something here, or one of these guys. There's all kinds of JavaScript probably in here that defines, there we go, a nice minified JavaScript piece. Hopefully this is looking good on our OBS Studio. So this data, the part in between that's caching, loading data, that kind of thing, that's the controller. So the model is the data itself, the view is the dash line, the controller is whatever code is in between that's putting all it together. That kind of structure um, is part of object-oriented programming all the time. If I look for an MVC programmer job, for instance, there's people looking for programmers based on understanding things like MVC because of its importance in programming. That's really the reason for talking about these concepts. Okay. If we remember, there were simple languages like machine language, assembly languages that could just move objects around in memory. Move pieces of data around in memory, like a string, an integer, um, a floating point, that kind of thing. And those languages, the machine languages, assembly languages, didn't have any concepts of objects. The idea with those was this is towards the beginning of programming, the beginning of software development, beginning of any kind of development in that sort of fashion. And most of that code could only do a few things, right? When they first developed processors, the general idea was to figure out how to do math, right? You've got driving factors that made this happen, and most of those driving factors are things like military, business. They were looking to process things like payroll, sales, that kind of stuff faster, right? So you're looking for ways to process numbers. That's what's most important. That's what paid for all this development. You know, if you think of IBM mainframes, these big machines that many companies shared, a lot of this initial development was done for this kind of hardware. These pieces of hardware were large, stored at universities or large businesses, and then shared, similar to how cloud services are done today, right? So all that stuff was really just done in most cases for math, business, that kind of stuff. Um, as PCs in the 80s became prevalent, people could buy an IBM PC or, before that, kit PCs, um, and programming became more of a normal everyday kind of thing. Um, as a matter of fact, I was just reading some reports about top programming languages and business and what's going on in 2020 and 2021. There's a lot of discussion about how programming isn't really that niche market. Lots of people should know how to program now. And that's really just the evolution of what happened here with IBM PC. As more and more people had PCs and development became more and more about other business departments beyond just finance, keeping track of numbers. And computers themselves became more advanced. There was more devices. We had higher level languages developed. This really started with um, C and C in its development for Windows, Linux, AIX, Unix, that kind of stuff. And in the middle of there is procedural languages. So before we have really high level object oriented programming languages, we have procedural languages, right? So those are basic COBOL, Fortran. Those are the kind of code that runs a procedure with a series of line numbers. So if we look at this one, let's see what this one looks like. If we look at how this program is written, basically there's a line number at the beginning that's like a hard-coded number inside the program. So in this case, this program runs from 24 to 41 specifically. So if I want to add anything else, I've got to write routines to bump out of it or move things down. everything runs procedurally in order. If I want to hop around, I can use different subroutine names and go-to statements to do some moving around, but in general, I start at the beginning and go to the end, and I run it, and it's over. And it's meant for batch jobs, right? Where you've got some mainframe time. I've got some mainframe time. We buy that time and use it to run payroll, get paychecks out, that kind of stuff. So those procedural languages are kind of in the middle. And C was really a lot of the impetus of object-oriented languages. I mean, these have become a lot more than just C. Java, Visual Basic, .NET, other .NET, C Sharp, that kind of stuff, Python, etc. that we've looked at. Even JavaScript supports objects of a certain type. When we talked about that, we'll talk about that some more with ECMA script and that kind of stuff. But general idea here is that object-oriented languages were the first where you could actually do things like MVC and keep track of how classes are modeled to objects, have something that represents a bank account, a checking or savings account, or a mutual fund, or an IRA, and that kind of thing, and have a series of rules, blueprints that are built into those classes, right? Our classes are those objects that have a series of methods within them and different events that those objects can respond to. So, attributes are things like the name for an account, right? Maybe the account balance, the date the account was first started, that kind of stuff. Pieces of data usually is what an attribute is, right? And then events are something we respond to, and methods are functions within the class. And we'll look at these in a few seconds. I just want to cover constructors. Remember that one also. The constructor is a special method that's named after the class itself. And we looked at those through an example. Here's Griselda. Oh, that's our Android version. Let's see. Yeah, this looks good. So, again, these links are in CourseWeb, but I'll put some stuff below the video also. So this would be our Griselda 03 2020, and let's do this on the D drive. We'll do that. That sucks. Let's see if we got it this time. Alright, that looks good. So, the general idea here is I have GitHub Desktop installed, right? And that allows me to go to a repository, click on clone or download, and then open in GitHub Desktop. I did that, and then I go to the repository and show and explore. Okay, this Griselda example here is from Visual Studio. Let's pop this open. This will allow us to look at some examples and cover attributes, methods, and events, inheritance, right, that kind of thing. Let's see what we've got here. Yeah, it looks like these files are missing. So, there's a couple things I wanted to check out: attributes, methods, and events, um, inheritance, and I wanted to look at classes in C Sharp and classes in Python. So this is the first part. We'll cover attributes, methods, and events, and then we'll look at an example in Python also. Okay, so in our final example, we had in our main method for our program class, we were making some Griselda members, and a Griselda member is an inherited class that inherits from wrapper. Okay, so we could have, in talking about inheritance and attributes and methods, let's add a new item. So we've already got a Griselda member kind of wrapper. Let's add mumble wrapper. So we've got a mumble wrapper, and we want to have this mumble wrapper also import from the wrapper class. Let me boost this up. So our Griselda our Griselda member inherits from wrapper, right? If we go to definition, there's our wrapper. A wrapper can have bars, and they can sing, and they can rap. And our mumble wrapper also inherits from wrapper itself. So mumble wrapper, God, who are some good mumble rappers? Mumble rap. Who started this mess, anyways? God, horrible. First, let's see. Gucci, Chief Keef, Future. I don't know why DOS effects would be put in. There's no reason. I should edit this right now. There's no reason that DOS effects should be talked about in reference to mumble rap. Something. I'm not really sure. Gucci. I don't know. This is all questionable. I don't know. This really isn't the point. Let's just go with Chief Keef. Alright, so we're going to say, I don't know, we'll pick on him. So we have a mumble rapper. So we'll say Chief Keef is our mumble rapper. So we can go back to our wrappers and add more attributes. So here's our example of attribute. Can mumble. So this is one of the advantages of inheritance in object-oriented programming. So we have a base wrapper that had some attributes that already existed, have bars, and can sing. So we added can mumble, and the advantage here is that for these mumble wrappers, we can have a mumble wrapper constructor, right? And we can say can mumble is certainly true for these guys, but have bars, I think is probably false. I mean, and then can sing might be true. I mean, who really cares? But the idea is that we can add that, then we can go back and support it, right? We can be sure, like, these guys can mumble equals false. They're not going to participate in any of that stuff. But then, if we want to here, we can, in addition to making Griselda members, we can have a new mumble wrapper, Chief Keef, is that correct? Yep, alright, equals new mumble wrapper, and then we'll put his name in here. I made a mistake. I have to also support this. And this is one of the things that we have to think about when we're doing any kind of inheritance, right? At this level, excuse me, our name is defined down here. I don't know if that's right, you know. I think, and we we shouldn't do that. And up here in wrapper, we should add our name there. Yeah. And then attributes also have keywords like public, private, and protected, right? That define whether they're accessible in the class itself, private, accessible in the class itself, and classes underneath it, protected, or within any class in this namespace, public, like this. So name, we want that to be public. We could add a getter and setter and be fancy, but now since we do that, we don't even have to have it here, right? It's defined in wrappers, and any other wrapper types that we add in the future automatically have it. So that makes things easy there. It's an example of inheritance and attributes. Okay, so methods, we have this wrap method here, right? So one of the ideas that you can do in object-oriented programming, right, is I can have under my wrap method here, I can have a base wrap method that defines wrapping for a wrapper is returning a string, some amount of character data. It might be none, could be perfectly formed lines, um, but then my mumble wrapper themselves, they can take that definition and return their own version of it. So mumble wrappers can return some crap that for some reason people want to listen to, and then the Griselda members can return not crap. And everybody, though, no matter who they are, oops, excuse me. Notice I need a public keyword here for my constructor also. No matter who they are down here, I can call Benny the Butcher, and I can say wrap, and I can call Chief Keef, and I can say wrap. Okay, so that is polymorphism, where I can have a method and override it and have that work different in different inherited versions. So pretty cool. Again, it's kind of a silly example, but the idea is understanding the basics of it, right? This also kind of illustrates a class in C#. You've got methods that have signatures with curly braces around them, right? You have attributes inside the class itself also. Here's the class itself. And then inside that class, or excuse me, outside that class, you have the namespace wrapping it all up. So these are all in the Griselda example namespace, right? Some of them inherit from other classes. Others don't, but they all have that same namespace. So understanding how the class looks is really the point of that, okay? The other thing I wanted to talk about was classes in C# and then classes in Python. So Python I like to use because that's one of the real picky examples. C# is a lot like JavaScript, where you can have any kind of funky formatting. Let's find a stupid looking JavaScript example. These are nicely formatted. What I really need is something that's minified. Let's see if we can look at this one. This is an application that I manage for a company in town. Excuse me, an organization in town. Yeah. And see how, even though there's all kinds of different stuff going on here, if statements, whatever, doesn't matter. The formatting always works. Excuse me, the code always works, no matter what the formatting is. So, that formatting isn't important. in JavaScript and C Sharp, the compiler just runs with it. However, in Python, that is way different, right? In Python, we know that formatting is extremely important. Um, this is a sample Python class. There is some more that we looked at in our textbook. Let's see here. I wonder if we have a link to. Do I have a link? I think they're just here for our JavaScript files. There's a link in the probably in the textbook too. There's some examples in the textbook that have Python and are in a GitHub repository. So let me just find where that link is. Fine. Let's see if I have it here. If not, I'll just download them from CourseWeb. Yeah. I know that in here there's a link to the GitHub version of them too, but they are also here. So these have lots of classes, lots of stuff all mixed up into here together. Okay. But the general idea here is if you look at a class definition, like this class definition for rectangle here, there has to be blank line before the class starts. The definition for the constructor, which is here on line 32, that has to be tabbed in 1, 2, 3, 4 spaces, right? And then the definition is tabbed in itself. The definition ends here where there's a blank line after it. So that's the end of the class. So it's not like C# where you have a series of curly braces and that really starts and ends it. The compiler is looking for everything to be organized perfectly. Okay. And we did some of that in class, and so you should have hopefully a good idea of how those work. But that's really the general main difference. If you look at the way the code is written, and we did some before, nothing really too complicated. Okay, it looks different when you first start with it, but once you get into it and check it out, most of it's not too bad. Let's see if we get further out here in an older chapter, excuse me, in a newer chapter. Yeah, this is an actual project, it looks like. Anything large in here? Oops. Similar kind of stuff. Our constructor defined with init, I-N-I-T, and then a series of methods afterwards. So, similar kind of stuff. So, the idea here, though, is for you to review class definitions in C# and Python, attributes, methods, and events, okay, and inheritance. And I have a discussion board activity set for examples of object-oriented programming. So what I'd like you to do is check this stuff out again, look through it, look through the Griselda example, look through some other examples found on GitHub, post some stuff on the discussion board. It's not going to be graded or anything like that, but I like to go in there and answer questions, that kind of thing. Throughout this process, I'll be available via Zoom, Teams, etc., that kind of stuff. I'll publish that stuff too later on. I wasn't planning on having any classes that were like a specific time, so you don't have to worry about logging in at certain times, but I can use any of those you want to work with you. Okay? So this will be our first class ending. Um, but let me know of any questions, and I'll be in contact soon. Thanks. Also, this album, I don't know why I'm putting it on the screen, but J Electronica, a written testimony. Okay, this guy, J Electronica, you may have heard of him. This has nothing really to do with um, anything in class, but for 10 years, rap fans have been looking, waiting, anticipating. This gentleman's debut album is finally out. Okay, it's been overshadowed, unfortunately, by everything else going on, but it's very good. All right, so again, that's nothing to do with class, but it's really cool. I want you to check it out. I put the title of this artist in the album here in a large font for it to make it very easy for you to see this. Go to YouTube, play this, do your homework. It's gonna work out very good for you. All right, thanks. So I'm sure you're wondering like what I've been doing during this extended break. One of the things I've been doing is hanging out with my son Emmett and playing Roblox. And I wanted to show you guys. This is my Roblox character. I have multiple Roblox characters. So this is just one I got a lot, but this is my favorite. I want you guys to check out my hair, how awesome it looks. I just want you to get a shot of that. Me and my son have a lot of fun with Roblox. We like to hang out in trucks and smash trucks and other trucks and cars and other vehicles and that kind of thing. He's got this styling hat situation going on, which is pretty cool, but it is not anything like this. I don't know if you know, but that hair is amazing. I want you to remember me like this.